So for dispensing 2, we're done with the ganatag na discuss on adverse drug reactions. Nahumana na to actually ang kanang sa adverse drug reactions, the different types. Now we proceed to koan. What you call this? Now we proceed to incompatibilities. This is not incompatibilities. Kanina slide. Okay. This is incompatibilities nga slide. So now we proceed with the next lesson on incompatibilities. So this covers now, by the way, your pre-final and your final examinations. So taas-taas ni siya ang incompatibilities. Medyo madugay ta, especially sa part about drug-to-drug interaction. So diha ta medyo malangay. Medyo taas-taas tag ma-discuss diha nga part. So for this meeting, atong humanon until before ta magsugod sa drug-to-drug interaction. So i-discuss na to ang tanan. And then if makaya pa nato, we will begin with drug-to-drug interaction. Kaya medyo taas-taas gid siya. So without further ado, let's start with incompatibilities. So as you know, incompatibilities, dili lang na siya incompatibility with your partner, with friends ba kaha, or with people. This arises also in your products, your drugs. So arises when 2 or more drugs or chemicals are combined. So dili lang na siya tao to tao ang incompatibility. It's existent also in chemicals and particularly your drugs. All right. So that's your definition of incompatibilities with relation to pharmacy. So there are 2 general types of incompatibilities. So first, we have your physico-chemical incompatibility, and then we have your therapeutic incompatibilities. So under physico-chemical incompatibility, we have your physical incompatibilities, and then we have your chemical incompatibilities. Under therapeutic incompatibilities, we have drug interactions. So dagantang klase-klase sa drug interactions. So ato na siyang tagsa-tagsaon og discuss. Now we start first with your physico-chemical incompatibilities. So again, I mentioned earlier, we have 2 general types of incompatibility. First, we have your physico-chemical incompatibility, and then under that one is your physical and chemical incompatibility. Then the second general type of incompatibility is your therapeutic incompatibilities. Under that is your different drug interactions. All right, so let's start first with physico-chemical incompatibilities. So for physico-chemical incompatibilities, we have physical and chemical. So for physical sa ta. So physical incompatibility, unsa man ni siya, the same drug is still present. Again, the same drug is still present, but the physical state is altered. Again, I will repeat. In physical incompatibility, the same drug is still present. The same drug is still present, but the physical state is altered. Again, physical state is altered. So first type under physical incompatibility. So for example, by the way, anang kuan physical state is altered from, let's say, from solid na liquefy siya, mana siya, as seen in the illustration. So from solid to liquid to gas. So first we have insolubility. So under physical incompatibility ni. This is the inability of materials to dissolve. This is manifested through different manners. First is precipitation. So precipitation. Next, we have dehydration or salting out. And then we have, what else? Temperature change. Okay, let's start first with precipitation. So you all know naman what are precipitates, diba? So these are, for example, if insoluble ang usa ka substance in a liquid, it will be forced out of solution. Muna mo precipitate siya. How about salting out or dehydration? So what is dehydration or salting out? So this is slightly soluble non-electrolytes from aqueous medium, and this occurs upon the addition of water. So again, non-electrolytes in reaction in an aqueous medium. So slightly soluble non-electrolytes when it reacts with an aqueous medium. Example, acacia mucilage plus your sodium chloride solution. So mo salt out ang acacia ani. Next, we have, so by the way, if you can recall, acacia mucilage is your gum in water ha. So kung acacia mucilage plus electrolytes like your sodium chloride, mo precipitate or mo salt out ang imuhang acacia. Another is hydroalcoholic solution plus electrolyte. So mo salt out or mo dehydrate siya to alcohol. Next, we have temperature change. So we have temperature change. So we have your endothermic and exothermic reaction. So for endothermic, example, A plus A substance equals B. There's increase in temperature and also an increase in solubility. Example is potassium iodide, boric acid. So for exothermic, A is equal to B plus A. So substance A is equal to B plus A. Increase ang temperature, mo lower ang iyang solubility. So at low temperature, solubility decreases, which therefore produces your precipitate. So the solubility decreases, forming precipitate. At low temperature, for exothermic, increased solubility in cold water. Again, so for endothermic, mas naglibog mo ha. Endothermic reaction, A plus A is B. So increased ang temperature, higher ang iyang solubility. So endothermic reaction. Next, exothermic, mura siya mo release. So A equals B plus A. So the higher temperature it is for exothermic, mas muhinay or mo lower iyang solubility. So increase iyang solubility only in cold water. So hopefully nasabtan to ninyo. Again, endothermic, endo, di ba? Endo is inside, exo is outside. So endo meaning inside the reaction, endothermic reaction, the increase in temperature increases the solubility. Kung exothermic, the increase in temperature will lessen its solubility. So a release of koan. Thermic meaning heat. So temperature change. So if you lower down the temperature, diha na mo saka ang koan, solubility in exothermic reactions. Next. So apart from insolubility, so again, I specified unsa na mga klase-klase ang sa insolubility. We have precipitation, salting out or dehydration, and then temperature change. So apart from insolubility, we also have liquefaction as another physical incompatibility. So in liquefaction, let's define the term eutexia. EUTEXIA. So this is the depression in melting point of solid or solids upon contact or in contact with other components. So this happens, liquefy ang solid at room temperature. So usually it happens at room temperature. Okay, of course, di ba, naibala naman nato na usually if you increase the temperature of something, like a solid kintahay, mukha yun na siya, mulanay yun na siya. But for eutexia, this happens at room temperature. So example ana na mga chemical or not really product, but chemical substances is your menthol. We also have your phenol, thymol, even your ASA. We also have camphor. So, intentional nga eutexia, by the way, we have camphor plus menthol, which is your Vicks ointment. Then we also have prilocaine at 2.5% plus lidocaine, still at 2.5%, which creates your eutectic mixtures of local anesthetic or your EMLA cream, EMLA cream. So, di ba usually kung local anesthetic, not necessary na siya imoagi sa imong system because ang anesthesia kailangan lang siya at a certain portion of the body. So, na ay local application lang. So, muna siyang i-create ang prilocaine 2.5% plus lidocaine 2.5%, your eutectic mixtures of local anesthetic. So, kailangan siya mo-liquefy kay di ba? If you have already learned sa inyong biopharmaceutics, in order to be absorbed by the body, dapat mo liquefy or ma-form into solution ang imuhang drug na i-take, even kung imo siyang i-take orally. So that's the only way for the body to absorb the molecules responsible for therapeutic effect. Kailangan siya in solution form. Kay moray pamaagi para ma-absorb siya sa imuhang lawas. Samot na ni kay local application lang. So eutectic mixture to liquefy your solids. Again, it happens at room temperature. Okay. Next, we have hygroscopic. So familiar na mo ani. Hygroscopic, so this one absorbs moisture or water. This doesn't dissolve. Ang deliquescent, this one still absorbs moisture, but mo dissolve ni siya, mo liquefy ni siya. Like example ana is your sodium hydroxide pellets. Dali ra ka na siya mo liquefy mo. Deliquescent kay na siya nga substance. Next, we have effervescent. This one releases water of crystallization. And then we have efflorescent, releases water. Effervescent akong giingon. It should be efflorescent, releases water for hydration or crystallization. So sayo pa ko na ingon, yung effervescent. Anyway, balik ko na kung discuss. Under physical incompatibility, we already discussed insolubility. Under that is your precipitation, salting out or dehydration, temperature change. For liquefaction, I already discussed eutexia, hygroscopic, deliquescent, and efflorescent. So unsa ganitong intentional nga eutexia, you have your EMLA or your eutectic mixtures of local anesthetics, your prilocaine and lidocaine. For a while sa guys ha. For a while sa. So I had to pause the recording kay I had to drink water. Anyway, let's go back to our lesson. So I already defined to you eutexia. This occurs at room temperature, so depression in melting point of solids upon contact. Example na to is phenol, menthol, thymol, ASA or aspirin, and then camphor. So intentional, your Vicks ointment and your EMLA cream. Hygroscopic, I already discussed. Deliquescent, discussed na, and efflorescent. Now we proceed to the next type. We have, sorry, muna siya by the way, for liquefaction. Your hygroscopic, deliquescent substances. Next, we have polymorphism. So forgot to click to the next slide. So polymorphism, this one, the drugs exist in several crystalline states. Again, the drug exists in several crystalline states or structures called polymorphs of different properties. So polymorphism, drug exists in several crystalline structures called polymorphs of different properties. Example of that is cubic. So kung cube na form, that is your form of sodium chloride. So sodium chloride, especially microscopic na, tanawin ninyo siya in a microscope, it forms into a cubic-like appearance. So crystalline state na niya, cubic, ang sodium chloride. So to help you, memory aid lang, to help you remember kung saang forma sa kanina mga substances, kung sodium chloride gani, cube, memory aid is NaCO. NaCU. Na stands for sodium, Cu for cube. NaCO. Next, we have monoclinic. Again, monoclinic. So for monoclinic, we have sucrose. So memory aid for sucrose, SUMO. So monoclinic, sucrose, Su for sucrose, Mo for monoclinic. Next, we have triclinic. For triclinic, this is your boric acid or H3BO3, boric acid. So memory aid for this one is tribo, triclinic boric acid. Next, we have tetragonal, urea. So urea meaning 4 kabok letters, urea, 4 letters. So for tetra, 4, urea. Sabtan ra, memory aids. Ito ra nang balik ko nung discuss. Next, we have rhombic. For rhombic, we have iodine. And then lastly, for hexagonal, iodoform. So those are different examples lang on polymorphism. So again, polymorphism, drug exists in several crystalline structures called polymorphs of different properties. Cube, sodium chloride, NaCO. Monoclinic, sucrose, SUMO. Triclinic, boric acid, tribo. Tetragonal, urea, tetra, urea, 4 letters. Rhombic, iodine. Hexagonal, iodoform. So again, this is still under physical incompatibility. So what we have discussed na so far, we already discussed. Ako dyan hinay-hinayon nag-discuss sa para magsulat sad mo, kamulo mo maminaw ani, magsulat sad mo sa iyong notes. So for we discussed nga at incompatibility. So far, natay 2 general types, physico-chemical and therapeutic. So una natong gidiscuss ang physico-chemical. Under physico-chemical, we have 2 subtypes, physical incompatibility and chemical incompatibility. So for physical incompatibility, we have insolubility. Under insolubility, we have precipitation, salting out or dehydration, temperature change. Next, apart from insolubility, we have liquefaction. So under that is your eutexia, hygroscopic, deliquescent, and efflorescent. Third, we discussed polymorphism. So under that, we have cubic, NaCO, monoclinic, SUMO, tetragonal, 4 letters, urea, hexagonal, iodoform, triclinic, boric acid or your tribo, and rhombic, iodine. And then we proceed to the next physical incompatibility, which is sorption. So this is a collective term. Ang sorption, by the way, is the collective term for absorption and adsorption. Again, collective term for absorption and adsorption. So absorption is penetration into capillary spaces. Adsorption is surface phenomenon or interfacial. So as you can see in the slide, absorption, particles soak into the bulk of the other phase. Absorption, adsorption, particles stick to the surface of the other phase. So muna yung difference sa absorption from adsorption. Adsorption, water clinging to the sides of kintahay your beaker or your test tube. Absorption, like your drug being absorbed by the body. It enters into your intercellular spaces. Muna siya ang absorption. Alright. Klaro naman siya noon sa difference sa absorption from adsorption and vice versa. Next, we have volatilization. Again, volatilization. By the way, before ko proceed sa volatilization, for sorption, aside from drug, water clinging to your test tubes or beaker or other volumetric, we call this volumetric apparatus. An example of that is, let's say, mag-leaching. So, ang drug nimo, mo-leach, kintahay siya sa, for example, o an IV, intravenous ang administration sa tambal. And then, sorption can happen especially kung mo-absorb ang drug sa PVC tubing. Kaya diba, i-infuse ba na sa diretso sa imuhang vein. Or sa imuhang ugat. So, what happens sa sorption? Ang drug mo-absorb siya sa PVC tubing. Ang mahitabo ang leaching kung pabali. Sorption kung drug to PVC tubing. Leaching, pabali. Ang component sa PVC tubing moadto sa drug. So, remedy for sorption, instead of ang drug moadto sa imuhang body, adsorb na noon siya sa imuhang PVC tubing or kanang tubing, diha ka na moagi ang flow sa imuhang IV solution. Remedy ana is to decrease infusion time. So, notoriously sorbed, by the way, in PVC tubing, ang benzodiazepines, nitrates, and polypeptides. Again, leaching, bali. Ang components or materials sa PVC tubing ning adsorb sa imuhang drug. Muna ang leaching. Leaching, L-E-A-C-H-I-N-G. So, proceed na ta with volatilization. So, for volatilization, this is for drugs with high vapor pressure. An example, your volatile oils, your nitroglycerin, your ketones, esters, aldehyde, alcohol. So, these types of compounds are stored at low temperature and hermetically sealed. Again, hermetically sealed. Do you remember unsa nang hermetically sealed? Naan na sa inyong manufacturing ata, manufacturing pharma. So I'll leave it up to your pharma, your manufacturing pharma. So what is hermetically sealed? Unsay nakalahi ana sa sealed lang. Ang hermetically unsay nakalahi sa sealed lang. So, anyway, going back to our discussion. For drugs with high vapor pressure, of course, dali siya mo volatilize. Kung dili nimo siya i-store at low temps, samot na kay kung i-increase pa nimo ang temperature, samot siya og volatilize. So, instead na nakitambal na wala, kini volatilize na siya. Samot na ng mga volatile oils. Like, for example, kana sa inyong perfume, part ba na siya? Ang kanang volatile oil sa inyong mga perfume, di ba? Matingala mo, magkuan mo, mag-spray mo sa inyong perfume, niya kadugayan, mawala ang baho. Muna siya ang volatilization. Kay tungod kay high vapor pressure ang volatile oils. So dali siya mo volatilize. So of course, kanin yung mga perfume din niyo na siya ibalandra ug kuan init. Apart from that, your alcohol as well. Di na nyo na siya pang balandra og init kay mo vaporize na siya or mo volatilize hantod sa wala na yung mabilin sa inyong kuan. Inyong alcohol or even your perfume. You store at low temperature and then you seal it, hermetically sealed. So of course, hindi nyo siya iabrihan. Kaya kung ma-expose siya sa atmosphere, not necessarily atmosphere sa earth ha, meaning ka ng kuan ba? Your even sa room lang atmosphere, like i-open mo siya, hindi nyo siya i-seal or keep, mo kuan ra gyapon na mo volatilize ra gyud na, albeit slowly lang kay compare nimo sa kanang at high temps, of course, mas paspas gid siya ang iyahang volatilization. Next, we have water loss. So what happens in water loss? So for water loss, this is the reverse of liquefaction. So again, reverse of liquefaction. So this happens in ointments, emulsions, and gels. For a while sa, kasi I pause, although mo balik ko discuss kay ma-pause mo diretso ra ni sa ako ang pag-return. So anyway, for a while. All right. Going back to our discussion. So I think I ended unsa na mga types of substances na mo undergo sa reverse liquefaction or your water loss. So we have ointments, emulsions, and gels. So for ointments, this happens when it crumbles or mag-crumbling ang ointment. So naay water loss ana. Next is emulsion, you're cracking or breaking. So ma-separate irreversible separation of the continuous phase and other parts of your emulsion, etc. Next, your gels. So syneresis, so imbibition or swelling. Again, syneresis, SYNERESIS. So repeat, balik ko na ko tanan na discuss na to for physical incompatibility. So going back, so going back, para jud inyo ning ma-follow, I already discussed to you that incompatibilities happen when two or more drugs or chemicals, what do you call this, arises when they are combined. Two or more drugs or chemicals present incompatibilities. There are two types, general types, your physico-chemical incompatibility and your therapeutic incompatibility. So under physico-chemical, we have your physical incompatibility, which ato na nahuman earlier, and chemical incompatibility. Under therapeutic, we have drug interaction. So we discuss first sa ato ang physico-chemical, which is physical first. So ato ang na-discuss so far for physical incompatibility is insolubility. So again, be reminded, unsa tong under sa insolubility, we have your precipitation, salting out or dehydration, and temperature change. Same drug is present, however, the state is altered. Next, we have liquefaction. So I already discussed to you eutexia, hygroscopic, deliquescent, and effervescent. Under gihapon sa physical incompatibility, polymorphism. So drugs exist in several crystalline states. So I already discussed cubic, monoclinic, what else? Tetragonal, triclinic, rhombic, hexagonal, or hexagon. Hexagonal, sorry. And then I already discussed to you sorption, unsay nakalahi sa absorption from adsorption. Again, absorption, penetration. Again, penetration into capillary spaces or particles soak into the bulk of the other phase. Adsorption, this one is surface phenomenon. So particles stick to the surface of the other phase. We have your remedy for that one, especially in drug administration. So decrease infusion time. Kay notorious ang benzodiazepine, nitrates, and polypeptides being sorbed in PVC tubing. So kanang sa infusion of IV solutions. Leaching kung pabali from PVC tubing to drug. Then we also discuss vaporization or volatilization. So higher vapor pressure, you need to store at low temp and hermetically sealed. So unsa ganina hermetically sealed? And then examples are your volatile oils, ketones, esters, aldehyde, alcohol, and nitroglycerine. And then we also discuss water loss. So for water loss, we have your reverse liquefaction. So ointments is crumbling, emulsions, cracking, gels, syneresis. Now we proceed to chemical incompatibility. For that. So for chemical incompatibility, the original drug is no longer present. It may or may not retain form. So ang original drug, wala na siya. However, yung form, it could retain or could change to another form. Again, for physical incompatibility, same drug is still present, but the state is altered. But for chemical incompatibility, the original drug is no longer present and it may or may not retain form. So first example. First example for chemical incompatibility is your redox or your reduction oxidation reaction. To involve ani? Excuse. We have your reducing agent, oxidizing agent, and then the mnemonic Leora Geroa. Leora stands for Le, lost electrons, O, oxidized, reducing agent for Ra. Geroa stands for gain electrons, reduced, oxidizing agents. Do you understand unsa nang sa mnemonic? Kung mayong gani kag reducing agent, iyahang buhaton is to reduce the oxidizing. Ay, malibog mo ani. Ana na lang. Kung mayong kag reducing agent, iyang aim is to reduce something. Since silang duha man jud na, di man pwede mabuwag ng redox. So kung ang reducing agent mang reduce, gi-oxidize siya sa oxidizing agent. Tungod kay na-oxidize siya, ni-lose siya og electrons. For Geroa, gain electrons, reduced oxidizing agent. Since oxidizing agent siya, yung aim is to oxidize the other substance. But since kato siya oxidizing agent, ni-react ang reducing agent by reducing it gained electron. Sabtan na ba ninyo? Hopefully nasabtan na ninyo. Kaya mura jud na ang makatabang ninyo for life. Especially sa board exam. Helpful kaya ang Leora Geroa mnemonic. Leora, Leora, Geroa, Geroa. Kabalo naman siguro mo ani, di ba? So next, examples na ta for redox. Fats. Undergo siya oxidation for mo rancid ang fat. So this can no longer be used ang fat ani. Volatile oils, oxidation, form siya into resins. So this can be used. Olefins or alkenes. Apart from that, your glutathione, form to disulfide. You also have your steroids and catecholamines, your epinephrine, for example. So this one is clear, colorless, mo oxidize siya, mo pinkish. And then further oxidization, mahimo siyang brown. Precipitation na yun. Alright. Ang kaning redox reaction, sa inyo na ni siyang QC subject. Mas ma-discuss mo yun sa QC. Ako lang ani is to quick description on the different incompatibilities and different examples and a little explanation if need og explanation. So in the illustration, masabtan na ninyo, oxidizing agent is reduced and undergo siya reduction. Kay siya, iyang trabaho as oxidizing agent is to oxidize the reducing agent. So it gains electrons, muna siya. Leora, Geroa, ra gyud inyo hang ko na makatabang ninyo. Next, acid-base reaction. So for acid-base reaction, of course, it involves your acid and bases. So neutralization reaction. First, we have precipitation or neutralization reaction. So, di ba, ang formation is water and salt byproduct. For example, we have hydrochloric acid and sodium hydroxide. So it will form into sodium chloride and water. So salt of organic acid plus acid. Wait. Soluble, I want to discuss lang. Soluble salts of phenol, your carboxylic acid, barbituric acid, weak acid, phenol, and what else? Other carboxylic acids. These are your free acids. Next is, let's say, call this. So for salt of organic acid, when you add it or react it with acid, it will form into organic acid. For salt of organic base, you react it with, react it with base, well, you have your free organic base. Apart from precipitation neutralization reaction, we also have evolution of gas. So this is for effervescent preparations. So compounds containing carbonate or bicarbonate, then you react it with acid, will release carbon dioxide. Example of that is your magnesium citrate oral solution. Next, change or formation of color. So change in color. Well, this happens in your titration. Familiar mo ni, diba, sa inyong QC, titrimetry or titration, your alkalimetry and acidimetry. So here, mo change ang color sa indicators na to, depending on the pH, whether it's acidic or basic ang imuhang solution, in which the indicator is located or found. So change of formation of color, example na particularly is your, sorry for a while is your pH indicators. Next, muna siya acid base. Sorry, I tend to forget ko on moving the slide to the next. Next, we have hydrolysis. So for hydrolysis, substance, let's say we have substance AB. So you act it with water. So in hydrolysis, mabuwag na siya. Ang AB compound, when it undergoes hydrolysis, mo separate siya into A plus B. So examples for that one, this one is breaking up of bonds with water, ha? So most common type of incompatibility in hydrolysis. So example is your esters, your local anesthetics, or your aspirin. Amides, your local, your beta lactams, imides or amides? Imides siguro ni. Your barbiturates, and then glycosides, your ether bond. So ASA or aspirin plus water equals salicylic acid and acetic acid. So what's responsible for the vinegar odor smell in aspirin when you undergo it with the hydrolysis nga reaction? So mabuwag ang acetyl salicylic acid. So from acetic from acetic and your salicylic acid. So ang responsible for the panghi nga odor or vinegar odor is your acetic acid, of course. Next, we have photochemical degradation. So it happens with photooxidation and photolysis, your oxidation and breakdown. Example for this one is your nitroprusside. This is the best example of photosensitive drug. So what happens here in nitroprusside for a while. Okay, going back to our discussion, example for photochemical degradation, we have your nitroprusside. So this is the best example of photosensitive drug. So this is the drug of choice for hypertensive crisis. If oxidized as CN is released, what is CN? So na siyang substance in your periodic table. And your vitamin B2. So again, drug of choice for hypertensive crisis ang nifedipine and nicardipine. Right. Okay, now we proceed to apart from photochemical degradation, we have optical isomerism. So this only for drugs capable with optical rotation. So change in optical activity of a drug that may result change in its biological activity. So example for that one is racemization on thalidomide for morning sickness, which is teratogenic. Again, thalidomide, teratogenic ni siya. Fukumilia, do you remember that one? Anyway, that's for optical isomerism. So under that is racemization. Racemization. Sakto ra ba ko? Pagka-storya. Anyway, what else? We have gelatinization next. So example, Ana, is acacia, your gum mucilage, and then you react it with iron salts or ferric or ferrous salts. Then we also have cementation. Okay. Sorry about that. So for gelatinization, we also have cementation. So examples involve gyapon acacia gum mucilage. For example, for gelatinization, iron salts, and then cementation, acacia, and your bismuth salts. For cementation is synonymous to caking, by the way. Right. So far, na-discuss na to ang tanan physical incompatibilities and chemical incompatibilities. So before we proceed to therapeutic incompatibilities, let's do a quick break first. Part 2 will be uploaded with this one, part 1 ng lecture. All right, so without further ado, short break lang, 10 minutes or 15 minutes, and then resume ta sa to ang discussion para makastart na ta with therapeutic incompatibilities. Kaya mora ba dyan medyo taas-taas somehow na koan topic na itong i-discuss. All right, so let me pause the recording for a while. All right, so proceed na ta for therapeutic incompatibilities. So we start with therapeutic incompatibilities, drug herbal interaction. So here we have in your therapeutic incompatibilities naatay precipitant and object. So for precipitant drug, this causes or instigates the interaction. And then the object here is the one being affected by the reaction. So we start with drug herbal first. Later na ta sa drug to drug, kaya mura ba na ang medyo taas-taas atong i-discuss. Alright, so drug herbal. So for drug herbal, example. So before that, the eye therapeutic incompatibility when 2 or more drugs are administered and the response is different from expected. So again, we have your precipitant drug, the one that causes the interaction, and the object drug, the one affected by your reaction or your interaction. So for drug herb interaction, herbs are mostly tonics that triggers enzyme inducers. So nanan ni sa inyong biopharmaceutics nga subject. So ako ra po na siya i-discuss balik. Later na during drug to drug interaction. So example ana is your digoxin plus St. John's wort. So St. John's wort is an enzyme inducer. This is an antidepressant. So enzyme inducer ang St. John's wort. Kung enzyme inducer, so i-induce niya enzyme, the function is to metabolize usually. Decrease ang concentration sa imuhang digoxin. So what is digoxin? What is it used for? So nana sa inyong PCOL. So therapeutic failure tungod kay decreased concentration or amount of your digoxin, di na siya makaproduce og therapeutic effect. Next, we have warfarin or heparin or your low molecular weight heparin plus garlic or ginger or ginkgo biloba. So additive effect ni siya. Your garlic has antiplatelet activity. So it will lead to hemorrhage or bleeding. Okay, of course, nag-heparin na gud ka or warfarin. Kunya kuan pa jud ka garlic ka nga na antiplatelet activity, so mag hemorrhage or bleeding. So additive effect ni siya. Next, we have warfarin plus Asian ginseng. Asian ginseng is still an enzyme inducer. So for this one, warfarin example plus Asian ginseng. Example, what happens here? Decreased ang iyang anticoagulant effect for warfarin. Kung decrease ang anticoagulant effect, still the same function, bleeding or hemorrhage. Then we have valerian, your slipacil, and your barbiturates. So another example ni siya for drug to herb interaction. That is your sedatives. So kung take kag herb like slipacil, valerian, unya nag-take pa jud kag sedative, so intensify ang sedation. Still an additive effect. So double sedation na noon ka. Then we also have ginseng plus hypoglycemic agents. So increased hypoglycemic effect. So additive gihapon or intensified. And then we have licorice plus antihypertensive product. So this one is, by the way, licorice promotes sodium water retention. So increase ang blood volume for this one. Again, where water goes, where sodium goes, water goes. Sa mo ba na siya? Kung asa ang sodium, musudo ang tubig. So dili siya piso, dili na siya potassium in, sodium out ha. Lahi na siya. Kana kung asa ang tubig, asa ang sodium, diha sad ang tubig. So kung naay increased amount or concentration of sodium, of course, your water is being retained. Kung retained ang water, increased ang blood volume, which may lead to increased blood pressure. So, nag-take kag na kay ga-take kag antihypertensives and licorice, so antagonism, so nawala ang effect sa imong antihypertensive. And then we have mawang or your ephedra plus, for example, your caffeine or phenylpropanolamine or mawis, your MAOIS, ang kabalo mo unsa ng mawis, monoamine, sa ganit na. So, naanay sa inyong pico, I will not dwell much ha, unsa na mechanism of action, etc., etc. Sa inyo naman ang pharmacology. Ako ang concern here is unsay reaction when these two drugs or drug herb or drug food or whatever interacts, unsay mahitabo. So for mawang, your ephedra plus caffeine or your phenylpropanolamine or your mawis, increased blood pressure and irregular heart rate for this one. Again, going back, we already discussed physical incompatibility. I will not repeat unya na during review. Again, for physical incompatibility, we have two types, your physicochemical, your two types, physical and not general, chemical incompatibility. For physical, dagantag na discuss, usana ana insolubility, and then etc. etc. For chemical, we already discussed, so unsa man itong mga under for chemical incompatibility. For therapeutic incompatibility, we have your precipitant and object drug. So ay na siya, kalimtin ninyo ang precipitant and the object. Precipitant, the one that causes the interaction, and the object is the one affected by the interaction. So first type, we have your drug-herb interaction. Herbs are mostly tonics that triggers enzyme inducers. So kasagara, herbs, enzyme inducers. So unsay mga example, we have digoxin plus St. John's wort, WORT. So St. John's wort, antidepressant siya, component for antidepressant, and this is an enzyme inducer as well. So kung enzyme inducer, meaning ma-metabolize sa imuhang digoxin, di siya ma-absorb, so decreased concentration, there is therapeutic failure. Next, we have warfarin, low molecular weight warfarin. Low molecular weight heparin, and heparin plus your garlic, for example, which has an antiplatelet activity. So this one is additive effect, so mag-bleeding na noon. Another example is warfarin plus Asian ginseng. Another is your valerian plus sedatives or barbiturates. Still additive effect. Ginseng plus hypoglycemic agents. Still another additive effect, and then antagonistic effect, your licorice and antihypertensive. Next, we have ascorbic acid. No. Lahit na ni siya, by the way. Next slide. Makalimot jud ko ba sa next slide? Sorry about that. So, drug-food interactions at the first. So, for drug-food interaction, example for that one, basta drug-food interaction gani usually kani mga enzyme inducers gihapon kasagara. But not kuan raha, not specifically kana ra gyud na apoy laing interaction effects sa duha ang drug food. So quinolone and tetracycline plus you take it with milk. So what happens here? So or any calcium rich diet. So chelation or complexation. So this will result to resistance noon kay, di ba, antibiotic maning tetracycline. Then for quinolone as well, it will not reach effective dose. So there's probability of antimicrobial resistance noon tungod kay na complexation siya or na chelate. Next is, for example, we have warfarin. So warfarin plus green leafy vegetables. So ang green leafy vegetables like your spinach, kale, broccoli, it's rich in vitamin K. So wala tay effect or decreased effect of anticoagulant sa atong warfarin if we take green leafy vegetables kay rich man siya in vitamin K. So mura nagnuog walay effect imuhang warfarin kay nagtake ka og something enriched with vitamin K. So due to decreased anticoagulant effect na kay risk for thrombosis, for example. Next, we have kani kusog kaayo ni nga koan. Ipagbawal og take basta mainom og tambal kaning grapefruit. So let's say any drug plus grapefruit. So grapefruit is rich for enzyme inhibition. So kung mag-take ka grapefruit and then enzyme inhibition, iyahang i-increase ang effect of the drug kay iyang inhibit ang enzyme nga metabolize sa imong drug molecule. Next, we have metronidazole plus wine or beer or alcohol like. We have metronidazole and alcohol. So again, this will produce a disulfiram-like effect. So disulfiram-like effect, mo na siyang intensified effects of hangover like fatigue, thirst, rapid heartbeat, headache, mo na siya. So ang metronidazole, by the way, is an aldehyde dehydrogenase inhibitor. I-take mo siya with alcohol, no, magkakuan ka. Disulfiram-like effect. Next, we have, by the way, disulfiram inhibits aldehyde dehydrogenases, which accumulates your acetaldehyde, so that produces the hangover effects. Okay. So, ang alcohol, by the way, when there is alcohol dehydrogenase, ang imong acetaldehyde, instead na ma-accumulate siya, mo-form siya into acetic acid. So, mulasan ang hangover-like effects. So, kung ma-inhibit ang alcohol dehydrogenase, of course, ma-accumulate ang acetaldehyde, which is responsible for the hangover effects. Next, we have MAOIs and example, you take it with cheese or red wine or yogurt or sour cream, cured meat, liver, caviar, dried fish, or avocado. So mga tyramine-rich food. Again, tyramine-rich food. So kung mo take ka ana, MAOIs plus ka itong mga tyramine-rich food, this will result to hypertensive crisis. Again, hypertensive crisis. So tyramine or your decarboxylated tyrosine, this is adrenergic. So precursor ni siya of catecholamines. So your MAOIs increase, not increase. Your MAOIs plus you take it with tyramine-rich food, your catecholamines will result to hypertensive crisis kay it will increase man its concentration. So, magka-hypertensive crisis for MAOI plus tyramine-rich food. Next, we have spironolactone plus potassium-rich food. So, magka-hyperkalemia ka. Then we have griseofulvin, phenytoin, or metalazone, your lipid-soluble drugs. Take ka or kaon kag sisig, chicharon, crispy pata, or mga cholesterol-rich or fatty food. Increase absorption, increase bioavailability for lipid-soluble drugs. Next, we have digoxin in, for example, oatmeal. Decrease ang yung absorption ani kay ang oatmeal or your fiber interferes with the absorption of digoxin. So, decreased bioavailability. So, another is your biphosphonates, your mga dronates mo end og dronates nga klase sa tambal mo na ang biphosphonate, alendronate mo na siya. Plus any food. So again, alendronate, usually this is employed for osteoporosis. So if you take with food, ma-decrease iyang bioavailability. you take this one first. Muna siya ang administration instruction. You take this first early in the morning. Without food, yun na siya. Take it with plain water, and then only before breakfast. So standing or upright position for at least 2 hours. Dili ka pwede mag-take ani maghigda kay kung ani siya. Inom ni mo ani. Sorry about that. Kung maghigda ka ni mag-take sa alendronate or alendronic acid, kuan mag-irritate imo esophageal lining or your esophagus. So you take this before breakfast without food para dili siya mo-affect yung bioavailability. And you keep in an upright position for at least 2 hours. Next, we have acarbose or miglitol or your alpha glucosidase inhibitors. You take it with meal. Administered with food at the start of each meal ang kaning mga acarbose and miglitol. And another example is your for your biphosphonate, katong mga alendronate niya, i-take mo siya upright position to prevent po ni siya reflux. So we have anti-infectives plus any food. Usually, before meal, ang pag-take sa erythromycin, your stearate and ethyl succinate. Decrease magod ang bioavailability for if you take it with food, except kung mag-take kag penicillin and tetracycline. So usually, kung mag-take kag anti-infectives or antibiotics 2 hours before meal. Or kung nakakauna ka, at least 2 hours after. So proceed with drug lab test interaction. So ako ni i-review, recap na ko tanan na discuss na to so far before ta mo wrap up sa discussion na to for today. Siguro dili na makaya na to discuss ang drug to drug, so next meeting na. When I say next meeting, meaning after Christmas break, kay murag mo end na atong klase by December 18, I think. So, di na ta mag-meet ana December 18. That's my Christmas gift to you guys para makapahuway na mo, maka-enjoy mo sa inyong Christmas break. So, humanon lang na ko ning sa drug lab interaction, and then ato na dahil i-wrap up tanan, recap ta sa natanan na discuss. And then, I'll see you dayon next meeting, pohon-pohon. So, by January na. So, para mahumanan ni nato, let's start discussing drug lab test interaction. So, example for that is, we have rifampicin. So, rifampicin plus or vitamin B2 or chloroquine or metronidazole plus urine analysis. Magka-false positive result ka. Nga naman, for rifampicin, red-orange ang iyang epekto kung mo take ang rifampicin, mag-red-orange imong ihi. Kung vitamin B2 sad, intense yellow. Kung chloroquine sad, brown. Kung metronidazole, medyo ash-gray urine. So, if mag-urinalysis ka, na kay false positive result. Mag-take ka ng mga tambala. So, next, we have ascorbic acid. So plus glucose test. So ascorbic acid is a reducing agent. And then glucose test for reducing or non-reducing agent. So magka-false positive ka. Why man? Because vitamin C can increase your blood sugar levels. So for glucose test ni siya. Next, we have allopurinol and blood cholesterol test. So this one can still result to a false positive test result or false positive result because allopurinol can increase cholesterol levels. So we're done for drug lab test. So recap ta sa tanan natong na-discuss so far. So okay. So what we have discussed, we started already with incompatibilities. Now let's go back here. Okay. For incompatibilities, we already discussed that there are two general types. And this arises when two or more drugs or chemicals are combined. So we have your physicochemical incompatibility and therapeutic. Under physicochemical, we have physical incompatibility and chemical incompatibility. So for physical incompatibility, we have insolubility. So what happens here? The same drug is still present, but the state is altered. So for insolubility, inability of materials to dissolve manifested through precipitation, salting out or dehydration, and temperature change. For liquefaction, still under physical incompatibility, we have eutexia, depression in melting point of solids upon contact, and it occurs at room temperature. Intentional eutexia is your Vicks ointment and your Emla cream. We also have hygroscopic, deliquescent, and effervescent substances. Next, we have polymorphism. So drugs exist in several crystalline states, your cubic, monoclinic, tetragonal, hexagonal, triclinic, and rhombic. I already discussed to you the memory aids, NACUS, SUMO, TRIBO, tetra or 4 letters, iodoform and iodine for rhombic and iodoform hexagonal. Next, we also discussed about sorption. So for sorption, this is a collective term for absorption and adsorption. So again, for absorption, this is a penetration into capillary spaces. So particles enter into another phase. Adsorption, this is surface phenomenon. So interfacial rin siya, particles stick to the surface of other phase. An example is drug to PVC tubing, leaching kung PVC tubing to drug. Remedy, decrease infusion time. And unsa tong mga notoriously drug molecules that are absorbed in PVC tubing, your benzodiazepine, nitrates, and polypeptides. Next, we also discuss about volatilization or vaporization. So these are for compounds with high vapor pressure. Example, ana, your volatile oils. So you keep it in hermetically sealed container and at low temperatures para di siya mo volatilize. Then we also discuss about water loss. So this is the reverse of liquefaction. It happens in ointments, emulsions, and gels. For ointments, crumbling, emulsions, cracking, gels, syneresis, or the imbibition of or swelling of the gel. Now we proceed to chemical incompatibility. So the original drug is no longer present, but it may or may not retain form. So the reactions include your redox. So be reminded of Leora and Geroa. Next, we have acid-base reactions. So we have your precipitation or neutralization reaction, evolution of gas, and change in color, which is used in titration when you employ indicators or pH indicators. Next, we have hydrolysis. So this is the breaking up of bonds with water, most common type of incompatibility. It happens in esters, such as your local anesthetics, amides, like beta-lactam, and glycosides, your aglycone, which has the pharmacologic activity, and the glycone. So, nana sa inyo, PICOL. Next is photochemical degradation. So your photooxidation. Hala, morg na-skip ni nako ang photochemical degradation. Did I skip this part? I believe I skipped this part. Wait, for a while sa ha. So I didn't skip this part. I forgot. So photooxidation, this is the oxidation. And photolysis is breakdown. So example na mga drugs na ma-affected is your nitroprusside. So the best example ni siya for photosensitive drug. So drug of choice for hypertensive crisis. Another is your vitamin B2, and then we also have cisplatin and nifedipine. Again, your sodium nitroprusside is a potent vasodilator. So remedy ani is of course to protect it from light. You take it's given at night or cover the IV line with carbon paper para di gid siya mo interact with light. Next is isomerism. So for isomerism, optical isomerism. So only for drugs capable with optical rotation. So change in optical activity of a drug that may result change in its biological activity. Again, we have racemization. So conversion to enantiomorph until 50% is rendered inactive. Spontaneous reaction ni siya. So 50% active, 50% inactive. So I forgot to discuss this part di ay. Ako rang gihatag is an example. Example for this is your thalidomide, which was used for morning sickness until nahibalaan nga teratogenic siya tungod sa phocomelia. Then we also have geometric isomerism. So example for that is isotretinoin. So the isoform and the transform. Next, we have gelatinization, so gel formation, so acacia and ferrous salts. And then cementation or cake formation, acacia plus bismuth salts. So that's it for chemical incompatibility. So I discussed also, ni proceed na ta sa therapeutic incompatibility. So under that is drug interactions. So this happens when two or more drugs are administered and response is different from what is expected. So naatay two components for this one, basta gani drug interactions, naatay precipitant drug and object drug. The precipitant causes the interaction, the object drug is the one affected by the interaction. So first, we discussed about drug-herbal interaction. So herbs are mostly tonics that triggers enzyme inducers. So example for that is digoxin plus St. John's wort. So enzyme inducer ang St. John's wort. Therapeutic failure of your digoxin kaya mo decrease yung concentration. And then we have warfarin plus low molecular weight heparin or heparin plus garlic, which is antiplatelet activity. So additive effect, bleeding. Warfarin plus Asian ginseng. So still, this one decreases bleeding. Sorry about that. Decrease anticoagulant effect. And then valerian plus barbiturates, your sedative hypnotic, which valerian is also a sedative hypnotic. So additive yung effect, so double sedation. Then we have ginseng and hypoglycemic agent, so increased hypoglycemic effect, so additive gihapon. Licorice plus antihypertensive, so antagonism, kaya ang licorice promotes water retention, sodium water retention, so increased blood volume. When there's increased blood volume, saka po ang blood pressure. So antagonism. And then we have mawang or your ephedra plus caffeine, phenylpropanolamine, and maui. So increased blood pressure and irregular heart rate. So apart from drug herbal interaction, we also have drug food interaction. So for drug food interaction, we have quinolones plus tetracyclines plus you take it with calcium rich diet, like for example, milk. Take ka og milk niya, nag-inom ka quinolone or tetracycline. So chelation or complexation, so it will not reach effective dose, which may lead to resistance, for example, antibiotic resistance. We have warfarin plus green leafy vegetables like your spinach, kale, and broccoli, which is rich in vitamin K. So na-reduce ang effect of your anticoagulant warfarin or nawala dyan ang effect. Drug plus grapefruit. Grapefruit is an enzyme inhibitor, so increased effect of the drug. Metronidazole and wine or beer or any alcohol. So aldehyde dehydrogenase inhibitor ang metronidazole. Kung imo siyang i-take with alcohol, you'll have disulfiram-like effects, so intensified effects of hangover. Again, kay ang metronidazole is an aldehyde dehydrogenase inhibitor. Aldehyde dehydrogenase is the enzyme that will convert your ethanol from acetaldehyde to acetic acid. Kaya kung mag-accumulate ang acetaldehyde, diha ka hangover effect. And then we have MAUIs plus your tyramine-rich food, your red wine, cheese, etc. So hypertensive crisis. Spironolactone plus potassium-rich food, mag-hyperkalemia. Griseofulvin, phenytoin, metalazone plus cholesterol or fatty food-rich foods like sisig, chicharon, crispy pata. So your griseofulvin, phenytoin, and metalazone are your lipid-soluble drugs. So increased absorption, increased bioavailability. Digoxin plus oatmeal interferes with the absorption, so decreased ang bioavailability of digoxin. Then we have bisphosphonates, your alendronates, plus any food, decreased bioavailability. You take this first in the morning with plain water and remain in upright position to prevent reflux. And then anti-infectives plus any food. Example is your erythromycin. You take it before meal. Kaya nga no, i-decrease ang bioavailability if you take it with food. Except kung mo take penicillin and tetracycline. I take it usually 2 hours before meal, kaning mga anti-infectives. And lastly, for drug and lab test interaction, we have rifampicin or vitamin B2 or chloroquine or metronidazole plus urine analysis, which may produce a false positive tungod ka ang rifampicin, red-orange ang imong ihi, vitamin B2, intense yellow, chloroquine, brown, and metronidazole, ash-gray urine. Kung ascorbic acid po, this one is a reducing agent and you take it, you undergo glucose test. So false positive result for reducing agent. False positive result sa imong glucose test because ascorbic acid ascorbic acid can increase your blood sugar level. And then lastly, we have allopurinol, which promotes production of cholesterol. Plus, you take or undergo blood cholesterol levels na test, mag-produce siya false positive result. Tungod kay ang allopurinol can increase cholesterol levels. So we're done with the very first part for incompatibility. Na-discuss na nato ang physicochemical. And under therapeutic, na-discuss nato ang drug herb, drug food, and drug lab interaction. So ang medyo taas-taas nga atong i-discuss is under drug-to-drug interaction. Taas-taas gyud siya nga discussion because we will tackle for pharmacodynamics and pharmacokinetics. So medyo taas-taas atong discussion for this part. So thank you so much for listening to today's discussion.